Hello everyone. Um, Welcome to our programming with C++ course. I go by the name Faustina Petra Agabio, and we'll be exploring one of the most powerful and widely used programming languages in the world. So we are starting with lecture one, where we will get our first taste of what C++ is all about. So moving on to the objectives. In this chapter, you'll be introduced to C++, learn why learn why we should use C++, learn difference between C and C++, learn the object-oriented concept of C++, and also learn standard library components like input or output
Continue. Continue.
stream.
Sorry.
Sorry. Okay. Yeah. Understand the C++ program development process flow, difference between process and threads, explore C++ programming in code blocks. And so moving, so what is C++? C++ created by Brian Schuster in 1819. Okay, so to proceed, let's start with some history of C++. So, what is C++? Let's start with some history. C++ was created by a brilliant computer scientist named Brian Schuster in the year 1979. That's over 40 years ago. Initially, it was called C with classes. And if you are wondering what classes mean, don't worry, we'll explain that later. The name C++ was actually coined by Risk Maxim in 1983. The plus plus part is actually a programming symbol that means add one or make it better. So C++ literally means C, but better. Okay, so the language was commercially released in 1985, and it evolved from the C programming language in 1998.
That's great. Let's move on to the
Moving on to why we should use C++. Now you might be asking, why should I learn C++? There are so many programming languages out there. It's a great question though. First, C++ is used in virtually every computing system you can think of. Okay, from you from your smartphone to the biggest supercomputers. C++ is there making things work. And also, secondly, it's incredible efficient and close to the machine. This means C++ programs can run very fast and use computer resources effectively. Okay, it's what we call a system programming language. System programming language, perfect for building operating systems, games, and then high performance application exploits. So thirdly, C++ supports object-oriented programming, which we'll explore in detail. This makes it easier to organize and manage complex programs. And then fourthly, C++ is a compiled language, which means your code gets translated into machine language before it can run. This makes it faster than interpreted languages. And finally, C++ allows you to write modular programs that can work on various platforms, like Windows, Mac, and then Linux and more. Moving on to the object-oriented programming. Now let's talk about object-oriented programming, or OP or OOP for short. Yes, so this might sound complex, but let me explain it using a simple analogy. Imagine you are designing a car. In traditional programming, you might write separate pieces of code for your engine, the wheels, the steering wheel, and so on. In object-oriented programming, you create objects that represent real-world things. So you'd have a car object that contains all the data about the car, like its color, speed, and fuel level, along with all the operations you can perform on it, like start the engine, accelerate, or brake. Each object combines both the data and the operations that work on that data into a single unit. Okay. This makes your programs more organized, easier to understand, and easier to modify. Continue with object-oriented programming. When we say a programming language implements OOP, we mean it provides tools and features that makes it easy to create and work with objects. As you learn C++, you discover three important things. First, how to represent data in computer memory. This is like learning how to store information about your car objects. Second, how to manipulate that data, like changing the car speed or fuel level. And then thirdly, how to implement operations, like the actual code that makes the car accelerate. You also learn to write algorithms, okay, which are step-by-step instructions for solving problems, and also implement them in C++. That's what we call algorithm. And the key insights of object-oriented programming is learning how to combine data and operations into a single unit called an object. This is revolutionary because it mirrors it mirrors how it mirrors how we think about real world things. Okay. C++ was specifically designed to implement object-oriented program, or object-oriented design, or ODD. But here's something important. OOD doesn't replace structured design. It works together with it. Okay. Think of it as adding new tools to your toolbox. not throwing away the old ones. Okay, you're just adding them. Now let's talk about some key OOP concepts. That's object-oriented programming. Don't worry if these terms sound intimidating. We'll break them down, okay? So first is the data abstraction. This means creating classes to describe objects. A class like a class is like a blueprint. If you want to build cars, you first create a blueprint that shows what every car should have and what it should be able to do. Okay. Um, Second is data encapsulation. This means controlling access to data and to object data. Going back to our car example, you don't want anyone to directly access the engine. Okay, so they should use the ignition key. Encapsulation works the same way in programming. And then third is the inheritance. This allows you to create new classes based on existing ones. If you have a general vehicle class, you can create car, truck, and motorcycle classes that inherit common features but add their own specific characteristics. And then final key concept is polymorphism. This Greek word means many forms, and it's actually simpler than it sounds. Polymorphism means that the same instruction that can have effects, um, different effects, and then depending on the context. For example, if you tell different vehicles to start, a car starts its engine. A bicycle doesn't need to start anything, and an electric vehicle starts silently. Same instruction, different implementations. This makes your programs more flexible and easier to extend new features. Moving on to um, a simple C++ program. Let's look at our first C++ program. Not worry if it looks confusing at first. We'll break them down every. The first line, hash include IOStream, tells the computer to include a library for input and output operations. Think of it as important tools you will need. Okay. So the second line, using namespace std, is like saying, I'm going to use the standard set of tools so I don't have to write std every time. And then int main and then the parentheses is where your program starts executing. Every C++ program must have a main function. And then the cout. Remember your cout should be in small letter. It's used to display text on the screen. The this is the cout symbol, looks like less than one. It directs the text to the output, and then end line. The end line means end line. Okay. The ENDL means end line. It's like pressing enter. So, and the return zero tells the operating system that the program finished successfully. Now let's understand what happens when you want to run a C++ program. This is a step-by-step process like following a recipe. First, you use an editor to create your source program. This is just a test file with your C++ code, like the example we just saw. Some statements in C++ begin with hash, like hash include. These are called preprocessor directives, and they are processed by a special program called the preprocessor before your main program is compiled. Next, you use a compiler to check that your program follows all the C++ rules and translates it into machine language. If there's an errors, if there are errors, the compiler will tell you what's wrong. If there are errors, the compiler will tell you what's wrong. Finally, you might use a software development kit or SDK, which provides additional tools to help create your program. The process continues with two more important steps. The linker combines your compiled program with other programs provided by the SDK to create executable code. Think of this as gathering all the pieces you need to run your code or your program. Okay. And the loader then loads your executable program into the computer's main memory. That's the work of the loader. And finally, the last step is to execute or run your program. This is when you see your program actually working. That's when you get an output. So compiling and linking. So let's dive deeper into the compiling and linking process. This is like quality control in manufacturing. First, you run your code through the compiler. If the compiler finds error, like typing mistakes or incorrect syntax, it will generate error messages. When you see errors, don't panic. Okay, when you see errors, don't panic. This is normal. You simply look at your code, fix the errors, and run it through the compiler again. If there are no syntax errors, meaning your code follows all the C++ rules, the compiler generates equivalent machine code. This is this is code that the compiler can directly understand and execute. Finally, the linker connects your machine code with system resources, creating a complete runnable program. Moving on to the loader and then executing. Loader and executing. Once your program is compiled and linked, the loader can place it into main memory for execution. This is like loading a game into your console before you can play it. The final step is executing the program. This is when your code actually runs and that's what you programmed it to do. Okay. Here's something important to remember. The compiler guarantees that your program follows the rules of the C++ language, but it doesn't guarantee that your program will run correctly. You could have a program that follows all the syntax rules but still doesn't solve the problem you wanted it to solve. That's why testing is so important. So, understanding process. Moving on to process, how you should understand. Now, let's talk about processes. A process is simply a program that has been loaded into memory along with all the resources it needs to run. Okay, think of it this way. Your C++ source code is like a recipe, as I said earlier on. When you compile and run it, it becomes a process, like actually cooking the meal using that recipe. So you get the recipe and then you use the recipe to cook your meal. Each time you run a program, you create a new process. If you open the same program twice, you have two separate processes running. Each process runs independently, okay, which means they don't interfere with each other. This is why you can run multiple programs on your computer at the same time. And then also moving on to threads, how to understand threads, understanding threads. Okay. A thread is a unit of execution within a process. We all know what a process is. As I said earlier on, if a process is like a restaurant, then threads are like the individual workers in that restaurant. Multiple threads can be created from a single process. Some processes are single-threaded. They do one thing at a time. Okay. Others are multi-threaded. They can do multiple things simultaneously. This is particularly important in modern programming, where we often want our programs to do several things at once, like playing music while downloading a file while responding to user input. And then moving on to virtual representation of threads. Virtual representation of threads. The slide appears to show a virtual representation of threads, which would be described during the lecture based on the visual content. And then visual representation of threads. Yeah, as I said. Threads and processes in programming. Let's trace through the complete journey of a program from idea of execution. Okay, so everything starts with a text file containing your programming code. This is what you type in your editor. Next, your program is compiled or interpreted into binary form. We all know what binary form is. So binary is the language of of ones and zeros. Binary is the language of ones and zeros. It deals with ones and zeros that computers understand. The computer understands ones and zeros. Then your program is loaded into memory where it really runs. And then moving on to threads and processes in programming. We all know what threads are and then what processes also are. So the journey continues as your program becomes one or more running processes. Remember, processes are typically independent of one another. They have their own memory space and resources. Within each process, threads exist as subsets. Think of threads as different tasks that the process can perform. Here's a key point. Threads can communicate with each other more easily than processes can. This is because threads within the same process share the same memory space, while processes are isolated from each other for security and stability reasons. So, in conclusion, we've seen what C++ is, and then who C++ was created, as who brought C++ in existence, and then we okay. So here is our lessons, and we'll proceed with the lecture 2 next time. Okay, so bye.